Remix IDE is a Ethereum IDE. This is online IDE. With the help of this IDE, we can write our smart contracts, develop your smart contract, execute, usually say the deploy your smart contract into test networks, and we can interact the blockchain using the smart contracts. Here, the advantage of this Remix IDE, what is that? This Remix IDE is integrated development environment, integrated development environment. Now we can just I'm changing the background color to better visibility. Okay, visibility. Here, the first icon is the File Explorer. You can view the workspace environment. By default, workspace is provided. If you want to create your own workspace, you can create your own blank workspaces, and you can clone from the GitHub repositories. You can connect from the local machine for the point with respect to workspace. By default workspace, some smart contracts. Some smart contracts. Now here the IDE beauty is no need to install any compiler in your local machine. In Ethereum smart contract, here we are observing the language is a Solidity programming. Solidity programming. This is also one of the type of object-oriented programming. To write smart contract, usually say that to automate your transactions using the smart contracts. Now, this idea beauty is the compiler, inbuilt compiler is there. After implementing your smart contract, you can compile. And you see the functionality of the smart contract, you can deploy the blockchain node. Usually say the Ethereum blockchain, that's why all smart contracts of the Ethereum is running on the Ethereum Virtual Machine. Yep, virtual machines. These are the existing test networks to node Ethereum node or Ethereum Virtual Machine to see the functionality of your smart contract. Now I am just checking the one small smart contract. Here we already written one smart contract. Smart contract. The smart contract is three numbers. Smart contract is three numbers. You see here the implementation. The first line of smart contract. First line of smart contract. The first line of smart contract license. You see the first one SPDX license identifier MIT. We are software package distribution exchange. You are getting the license from MIT identification purpose. Now, like any programming language, some import sections are there. Here also we are importing statement. Importing statement. That is a pragma is a directive and a solidity. And we need to mention the version of the compiler. We need to mention the version of the compiler. You need to mention the version of the compiler. The version of here, the compiler is version of the compiler is 0.8.40. Here, cap indicates starting from. Cap indicates starting from. Like a class name, here contract name. My smart contract here adding addition of 3 numbers. That's why we declare the one function. The function is the calculate sum and passing the parameters as a unsigned int 256 here. 256 nothing but 256 bits are repeated. Suppose you write the uint 8 nothing but unsigned int 8 bits are repeated. Based on the requirement, you declare the variable type. Here just example, I declare the uint type 256 bit A, uint 256 bit B, uint 256 C. Now my goal of the function is return the sum of these numbers. The structure of the Solidity function is a function name, parameters with the data types, and the type of the function access specified public. And also we need to mention the type. Return the value type also. Returns the uint type. Here we need to mention the type is a view or pure. Some keywords are used for some meant for some purposes. Here. The first program just explaining some of the 3 numbers in compilation. I want to compile this program. Just click the compile. Click the perfect. After compilation, when the Solidity high-level language code written in high-level language like C, Java, after compilation with the help of the Solidity compiler version, here IDE providing which version you require. You can use any type of version. Then select compiler version. After compilation success, the Solidity code compilation completed. Your IDE provided 2 types of codes. One is the bytecode. I'm just copying the bytecode. The bytecode. This is the bytecode of your smart contract. Usually say addition of 3 numbers. This is the bytecode. After compilation of your compiler, this bytecode you can deploy into the any Ethereum Virtual Machine. You can see the function. You can see the functionality of the smart contract. Second thing, the IDE provided active binary interfaces. Another code, active binary interfaces. This code you can use intermediary part of another code. Usually say the all while implementing the DApp, you are required active binary interfaces. Active binary code. This code can like your JSON code, like your JSON code. This IDE providing bytecode as well as ABI code. Now, after receiving your bytecode, you can deploy into the existing node, existing blockchain. Here, Ethereum Virtual Machine. Here, Virtual Machine. Here, by default, in this virtual node, having these much of records. And also, you just clicking the deploy button, your smart contract is compiled, your bytecode is deployed into the particular address. After, if a smart contract is deployed, some gas fees collected while deployment also. Now, I'm just clicking the deploy. Now, deployment is over. You can see the transaction here. Deployment is success. Deployment is success. You can see initially we have the 100 ethers. Some deployment charges they deducted from some ethers. That's why now your ether account balance is 99.99. Now, After deployment, your instance is created. Now you see the deployed contract. This is a deployed at a particular address. This is a deployed contract. The deployed contract at address is particular address, which account were uh, deployed that account. Now here our motto is addition of three numbers. Suppose here 3 comma 4 comma 5. I'm just going to calculate sum. This is some value to 3, 4, 5. Some value is 12. So let's say that after deployment, interact with the smart contract, nothing but passing values and get the output. Suppose I want with the 150 and 100 and 250, three numbers. Calculate. Now we can see we change the values, we can get the implementation of smart. For better understanding, I just did the small addition program. Small addition. This is compiling smart contract and deploy the smart contract in the existing environment provided by the IDE. This is a virtual machine node. And see the interact with the smart contract, nothing but a passing values and get out. Passing values and get the out.